everybody, Sir Beaton here and welcome back to another past paper practice video. In this video, we will be looking at a number theory question or number theory questions. So let's head straight into the question. So the question says, the diagrams below show a sequence of figures made up of circles with dots. Each figure has one dot at the center and four dots on the circumference of each circle. The radius of the fourth circle is 1 unit. The radius of each new circle is 1 unit greater than the radius of the previous circle. Except for the fourth figure, a portion of each of the other figure is shaded. So the figure 1, this last piece excludes figure 1, because with figure 1, everything is shaded. So let's head into the question. So the question says, complete the rows in the table below for figure 5 and figure n. So you want to complete this row here and this row here. So we see for figure 1, the number of dots will be 5, the area of the outer larger circle will be pi, the area of the shaded region will be pi because everything was shaded, and the total length of circumference of all the circles will be simply 2 pi. And for figure 2, we have the number of dots will be 9, the area of the outer larger circle will be 4 pi, the area of the shaded region will be 3 pi, and the total length of the circumference of all circles will be 6 pi. So for 3, we have the number of dots 13, the area of the outer larger circle will be 9, and the area of the shaded region will be 5 pi, and total length of the circumference will be, of all circles, will be 12 pi. So we kind of see a pattern here. So let's go to figure 5. Let's see how we can move from this here to this here and see if it will work for all the rest. So let's see if we multiply here by what number can get us closest to 5. Multiply by 4, and we add 1, we will get 5. If we multiply this by 4, 2 4s 8, and we add 1, we will get 9. If we multiply here by 4, and we add 1, we will get 13. If we multiply here by 4, and we add 1, we will get 17 as well. So we see we are multiplying the 5 by the 4, and then we add in 1. So 5 times 4 will be 20. 20 plus 1 will be 21. So that is it for that part there. Easy marks. So let's see. We already have this here to be 25. Let's look at the area of the shaded region. We're not seeing any link between these two. Let's look at how we can move from here to here, since the linkage between here and here is not consistent. So let's see how we can move from the figure 5 to 7 pi. So we see for this one, you can say 1 multiplied by 1, you get 1. But 2 multiplied by 1 will not give us 3. So let's try 1 multiplied by 2. That would give us 2. But we have a 1 here. So pi would be obvious. Pi would be recurring. So whatever answer we get, we'll just put pi to it. So we're looking at 1, 3, 5, 7. So 1 multiplied by 2 would not give me 1. But let's say if I subtract 1 from that. So 1 multiplied by 2 would give me 2. 2 minus 1 would give me 1. 2 multiplied by 2 would give me 4. 4 minus 1 would give me 3. So 3 multiplied by 2 would give me 6. 6 minus 1 would give me 5. So we see the pattern. Sometimes you multiply, and when you multiply a number, it works throughout. Okay. You try another number, and then you either add or subtract, and you keep until you get the answer. So this would be 5 multiplied by 2 would give me 10, and I subtract 1, which would give me 9 pi. So we see pi is recurring. So that would give me for that answer. So next one I want to move on to is the total length of circumference for all circles. So without any formula, let's see if we can get this answer. So we saw that this increased by 4, and then this increased by 6, and then we saw this increase by 8. So of course this will increase by, if the pattern continues, by 10. So this here will be 30 pi. And this here is the answer without any formula. Without thinking about any formula, which is the most difficult part for these kind of questions, we already have our 3 marks. So let's see if we can figure out a formula, because we'll need it for the next part. So what can we do? Let's see, we have 1 here, and we see, it's inconsistent here. So we have 1 here and we have 2. Let's see. For this one here, we multiplied by 1 and we subtract 1. Let's see what we can do here. So we're moving from 1 to 2. how can we move from 1 to 2? So let's try 1 multiplied by 2. That will give me 2. Let's try 2 multiplied by 3. That would give me 6. So let's try 3 multiplied by 4. That would give me the 12. Let's try 4 multiplied by 5. We continue with 1. That will give me the 20. So I keep adding 1. And 5 multiplied by 6 will give me the 30. So I keep adding 1 when I multiply. And that is how we can get this one here. So that is the formula. We can use another way in getting this same answer. So let's go back. Let's go now to the big part that gives people a lot of problems. So n. So the number of dots. Earlier we saw to move from here to here, we simply multiplying by 4 and we add in 1. So 1 multiplied by 4 plus 1. So this would be 4 multiplied by n, which is 4n plus 1. And for this one, well, we did not find this one here, but if we look here, we have 1 and we have 1 here. We have 2 and we have 4 here. We have 3 and we have 9 here. And we have 4 and we have 16 here. So we already seen a pattern of it being squared numbers. So n, this one would simply be n squared. And to get these ones here, we saw that we multiplied this by 2 and we subtracted 1. We multiplied by 2 and we subtracted 1. 2 2 is 4. 4 subtract 1 would be 3. So for this here, it will be n multiplied by 2 subtract 1. So 2 times n would be 2n subtract 1. And of course, this will be pi. We have to include the pi. And for this one here, we saw that we started off multiplying by 2, and then we multiplied by 3, then we multiplied by 4. So we can say n multiplied by, so we see this is 2, this is 3, so this will be, and this is 5, so we added 1 to this here. So this is n multiplied by n plus 1. And we keep adding 1 to what n is. And that will be the formula for this one here. So this one here was a bit tricky. We had to do some amount of thought, but we see that this is going for 7 marks. And as long as you can take your time and get these formulas, you will get 7 marks in your exam for this kind of question. And CXC will not give 7 marks away. As you can see, we had to do some amount of thought. So with that, we have our marks. So now let's move on to the next part of this question. So this one says, determine the value of n when the number of dots in figure n is 541. So the number of dots, so the formula is 4n plus 1. So they want us to determine what n is. So we know it's 4n plus 1. So we say the number of dots here is 541. So we just have to solve for n here. So 4n would be equal to, so this 1 is added, and we take it over, subtract. So 541, subtract 1 would be 540. So 4 multiplied by n is equal to 540. So n would be equal to 540 divided by 4. So n would therefore be equal to 135. So the value of n when the number of dots in figure n is equal to 541 is 135. So the last question says, write down in terms of p and pi the area of the largest circle in figure 3p. So we see we're dealing with figure 3p. So in this case, we see the figure numbers represented here. So they want the area of the largest circle. So we know the formula to find area is equal to n squared. And in this case, we're talking about figure 3p. In this case, n would be equal to 3p. So to find the area of this, it would be 3p squared. So 3p all squared would be the same thing as 3p multiplied by 3p. So the area here would be 3 times 3 is 9, and p times p would be p squared. So the area of the largest circle in figure 3p would be 9p squared. And of course, we must express this in terms of pi. So all of this here would be, we just add in pi. So you have to include pi in our answer because they want it in terms of p and pi. So with that, this has brought me to the end of this video. As you can see, this question here was slightly different from the ones that we did previously. But of course, the same kind of concepts will apply. So we just need to keep practicing, and keep practicing. So with that, I'll see you in the next video. Until then, take care.